Hello, everyone. This is Eden Wyson with the National Weather Service in Reno.
And this is Alex Hoon. Hey, everybody.
And this is a continuation of the fire weather refresher. So we've already gone through a few of the fire weather planning forecast elements and reviewed some of the red flag warning and fire weather watch details. And now we're going to get into a little bit more of the critical fire weather that can occur. So when we're talking about fire weather hazards, especially when it comes to red flag conditions and high winds, this here shown on the left, this is one of our worst case scenarios. When we're having an area of low pressure coming into the area, we have increased very windy ridgetop winds. We're seeing a lot of very strong jet across the Sierra. And what'll happen is that we have these conditions, these dry, windy weather conditions that get paired with these very dry fuel conditions. And this is one of those events that, this is a photo of the Collin Ranch fire that happened during November. So typically during a time of year where we wouldn't plan to see this kind of fire behavior, but because we had these very strong downslope, very strong dry, windy conditions paired with these very dry fuels, this is during that May to October timeframe, we can see these very dangerous critical winds popping up. Usually when we're looking at the forecast, we do have around a 3 to 5 day lead time when we're looking at these kinds of winds or this sort of potential for critical fire danger pushing into the area. Another critical fire weather condition that we can be concerned with is having those cold fronts push through the area. When you're seeing cold front passage, cold frontal passage expected in the fire weather discussion or in the synopsis, or even when you're reading the EXIT forecast, you can plan for a time period of erratic shifting winds, which is going to make that fire spread very fast and unpredictable. So if you see that cold front mentioned in the fire weather forecast or the fire weather discussion, that's really your time to pay attention and really key in on the timing, what the wind shifts are going to be, and just really kind of have your ears pricked up for that kind of information. You can see just in general on this, the left-hand side, this is a review of those S290 information, is that ahead of that cold front, we can really plan on those very strong south to southwest winds. And then as the cold front passes, we can end up with those north to northwest winds. So looking on the right here, you can see that initially we'll have a fire that is spreading or advancing, moving from the southwest to the northeast, but then as that cold front passes through, then we're changing the fire front, and we're actually you can see an expansion of the fire front from having a very narrow fire front with those southwest winds to having a very expansive fire front. So you can see changes in the fire spread, making it very fast and unpredictable. And again, this is just something you really want to key in when we're talking about cold fronts in briefings or emails or in those fire weather forecast discussions. So we had talked a little bit about those downslope windstorms on the first slide, but during these major storms that are going to occur during the fall through the springtime, we're going to be seeing those really, really strong southwest-west winds gusting above 60 miles per hour, well above 60 miles per hour. So the unfortunate part about these downslope windstorms is that you're seeing these very, very strong winds kind of get pushed across a mountain range. And what happens is that there's an area of stable conditions that's actually pressing down on those very strong winds and forcing those strong ridge level winds to go down the foothills, down to the valley floors. And that's where you can see these really very strong winds gusting 60, 70 miles per hour. And then you can actually end up with these different erratic winds in terms of rotors and things like that. So when we're talking about downslope windstorms, we're talking about very strong ridge wind gusts. We're talking about very strong foothill wind-prone area wind gusts. Galena is probably soaring into the 80 to 90 mile per hour gust range. And the other part that makes these downslope winds very dangerous is that when you force air down a mountain and down to the valley floor, it not only is accelerating, but it's becoming warmer and drier. So basically what we end up having are these very strong, very dry, very warm winds that can really produce dangerous fire behavior. So these downslope windstorms, they obviously aren't just isolated to our area. One of the more notable downslope winds across California are those Santa Ana winds, and that's where you can see these downslope winds developing during the fall and winter seasons. That cold, high pressure can form over the Great Basin area, and it just pushed those winds downslope into the coastal California areas. So when we're talking about having relatively light winds, light east winds here in Reno, we might be seeing wind gusts along the Sierra Ridge lines of 70, 80 miles per hour out of the east. But then on the other side in Northern California, those winds are very strong, widespread wind gusts, 50 to 60, 70 miles per hour, getting funneled down canyons and into all these areas. So really these can produce very worst case scenario conditions along the Northern California and Southern California areas with those very warm, dry conditions that can develop. So these sorts of winds were very impactful in multiple fires over the last few years, especially the North Bay fires with the Tubbs fire, tragically at the Camp Fire, and also at the Kincaid fire. So when you hear these terms being thrown around, Diablo winds, Santa Ana winds, or just downslope winds, this is another kind of watch out scenario where you really want to be aware of the timing and the wind gusts and strength and just paying attention. So this is just going to show the wind progression on the Camp Fire that's pushing down into Paradise. And this is one of those very strong downslope wind situations. And I'll let the loop run through. So what you're seeing here, and I believe the loop will start over here in a second. And Alex, feel free to chime in on this anytime.
Yeah, this is just a computer animation of what the fire activity can do, the fire progression under one of these downslope wind events. And it's very fast-moving, explosive fire behavior. You can see the ignition of this fire started a little before 7 a.m. and actually moved right down all the way into Paradise within a couple of hours. It only took a couple of hours for that fire to move. And some of these downslope wind events, these fires can move 10, 15, 20 miles in a day. It's very easy for them to move that quickly because of the spotting distances and the rapid rates of spread.
Yeah, thank you, Alex. And you can see that not just from the strong winds that develop, but you can get some funneling and terrain influences, which really kind of help to push that fire into those areas. So just to talk a little bit more about what we're using at the National Weather Service in terms of fire detection and trying to figure out like when is the earliest that we can detect a fire and where can we see these rapid changes developing. So these are just some screenshots from the Camp Fire from the Alert Wildfire cameras. And as you can see, it kind of goes through a progression here of just how explosive that fire behavior was. We had, detections of the fire, a little bit of smoke there at that 7 a.m. time frame. And then you can already see by 7:26, 7:30 that we have a well-established fire, explosive fire behavior, and nearing that pyrocumulonimbus status. So the Alert Wildfire System has been a great asset to us in terms of studying fires after they've happened and also having information ongoing and analyzing what's going on with the environment as the fire is progressing. So this is another shot, and Alex, can you remind me, is this also the campfire? I believe it looks like it is.
Yeah.
This is okay, perfect. This is actually a 4-panel of our new GOES satellite. Well, it's still relatively new, of the different satellite images that we can look at. So there are just different ways that we can look at the fire. So there's obviously, this is here in the upper right-hand corner, you can see that it's showing the fire progression there and the heat of the fire, and on the right-hand side as well. And you can really see the smoke kind of pushing in that upper left-hand corner. So these are things that we're using, these tools that we're using to detect just how intense the fire is burning, where exactly it's progressing. And these are things that we can pull up during the day and at night using several different channels with the GOES satellite. And with this 1-minute data, we can really take a look at just how explosive these fires are becoming and how they're progressing. And actually, one more thing I'd like to note here is that in this upper left-hand panel, you can actually see there's this rippling that forms these little waves, and you can just see how windy it was that day, as if you can just picture the wind moving over these ridge lines and ridges, producing those atmospheric waves within the airflow there. Very, very intense fire behavior. All right, I'll let Alex take it away from here.
All right, so the next fire weather hazard we're going to talk about is heat waves and the stability of the atmosphere. Heat waves are obviously a major impact to what we have in the fire season. A lot of people around our area, they say, hey, what's the most critical fire weather pattern that we have out here? And a lot of people think that it's thunderstorms or the gusty winds. But actually the high pressure, the areas of high pressure and these heat waves are actually probably the most significant for fire activity. June, July, August, these timeframes when we have multiple days or even weeks of above normal temperatures, the high temperatures in the 90s, even into the hundreds, those extended periods of hot and dry conditions actually lead to drying of the fuels, which in turn increases our fire activity. We get a lot more wildfires, human caused and lightning caused as well. Typically these, when the high pressure ridge sits over Nevada or over the Great Basin, that high pressure ridge typically breaks down at some point. And when you have that breakdown of the upper ridge, that's usually when we have winds, when we have lightning, all of that good stuff. But the heat wave is actually what initiates the crazy fire season. If you guys pay attention to one thing, when you're looking at the weather, when we have those extended heat waves, you can pretty much tell that the fire season is about to take a turn for the worse. Next slide, please. So heat, heat is directly related to the stability of the atmosphere. And as we have heat, very hot conditions near the surface, that warm air wants to rise, cold air wants to sink. And so that vertical motion of the air in the atmosphere, warm air rising, cold air sinking, is what we describe as instability or unstable conditions. And so what happens when we have unstable conditions and extremely dry air? Well, that's when we have explosive fire growth, and that's when we have the fire can actually start making its own weather. Really, it becomes plume dominated, and we begin to see plume dominated fire behavior. Next slide. So the Haynes Index is actually what we use as a measurement of atmospheric stability and fire behavior. Whenever the atmosphere becomes unstable and whenever we have a really dry moisture component, very, very dry air in the atmosphere, that's when we have the Haynes 5 or Haynes 6. And that just means that there's there's a very high potential for plume-dominated fire growth. If you have a low Haines index of 2 or 3, that means that the atmosphere is more stable and that you have more moisture in the air, which you have less potential for that plume-dominated fire growth. Depending on where you are in the country, they use Haines high, Haines mid, or Haines low. Out here in the Mountain West, we typically use a Haines high. So we're looking at elevations of the atmosphere between the 10 to 18,000 foot range. And then the next one there, Eden, this shows the Haines index numbers, going from a 2 all the way to a 6. And the 6 is the one where you have a Haines of 6, very high potential for large plume-dominated fire growth. One more, actually, that's okay. We can go ahead and show this. So a lot of times along the coast, if you guys go to fight fires along the California coast, they don't use a Haines index because the marine layer has a major effect on how it actually caps the atmosphere. This is actually a video of the station fire outside of Los Angeles, and you can see how unstable the atmosphere is. It's incredibly unstable. The Haines index on this particular day was a 6, and the marine layer has pushed offshore, so there is actually no marine layer to cap any of the vertical growth of this fire. So be very heads up when that marine layer pushes offshore that you can still see these very unstable, very dry conditions even along the California coast. And this is a perfect example with the station fire. Next slide, please. So the other instance that we saw that this occurred in a very big way was during the Carr Fire of July of 2018, and you can see just the vertical extent of this plume. As it became plume dominated, it created an enormous pyrocumulus, pyrocumulonimbus even. Although this one did not have lightning with it, we're going to talk about pyrocumulonimbus here in a little bit. But you can see those multiple layers, those layers of cap clouds, those inversions that the instability of this fire just broke right through those inversions like they were nothing. Next slide, please. So this next video is actually a time-lapse video of the plume over Redding as the fire burned into the Redding area. And you can see as that plume, number one, it's leaned over to the side, and you can kind of see that the winds are kind of pushing it from right to left. But as that plume continues to rise, it's punching through multiple layers of inversions because of the extreme instability of this plume. Really, the fire, once it became established and you have the instability of the atmosphere combined with the fuels and the topography, that's where we got this extreme fire behavior, and the fire itself began to make its own weather, which we'll talk about here in a little bit for the Carr Fire. Next slide, please. So before we move on to that, I wanted to talk about a few of those visual indicators of an unstable atmosphere. What can you use as a firefighter in the field? And we talked about the towering plume of smoke. Obviously, that's a huge visual indicator. If you have active fire on the ground, very active fire, or potentially extreme fire behavior, fire whirls, those are also visual indicators. Good smoke dispersion, gusty winds, good visibility, those are all really good visual indicators on the ground. If you're looking up at the sky, towering cumulus clouds, cumulonimbus clouds, thunderstorm clouds with virga or rain shafts and lightning, those are all indicators of instability in the atmosphere. That basically the atmosphere wants to move up and down when we see that. So this next one shows the visual indicators of stable air. So the atmosphere does not want to move up and down. The atmosphere wants to remain at rest. So visual indicators for that: flat stratus clouds in the sky, flat inversions. The smoke may rise up a little bit, but then it flattens out. Flat haze and fog, low fire activity. All of those are really good indicators of stable air in the atmosphere. The last one I wanted to touch on is the mountain wave clouds. If you see those lenticular clouds, the mountain wave clouds in the background, those are specific clouds that mean that there is a stable layer in the atmosphere, but then there is also a very strong ridge wind, a very strong winds at the ridge top level over those mountains. And those, later on in the day, those winds could potentially surface all the way down to the valley floor. So those mountain wave clouds should be a very big heads up for anyone that's working on wildfires, anyone who's a wildland firefighter. Next slide. So another instability indicator is a dust devil. Dust devils occur on hot days over dry ground. You have very hot air that's rising very quickly. It begins to rotate, and that's what we see as the whirlwind, the dust devil. These can last, for 20 minutes, 30 minutes at a time or more, 10 to 100 feet in diameter, and sometimes they can reach up to several thousand feet into the atmosphere. These are actually very common over freshly burned areas. You can, if it's over an area of black, and if it potentially has stump holes or any kind of active fire, that dust devil can turn into a fire whirl, or it can just roll over and spit out a whole bunch of fire embers, fire brands in hundreds and hundreds of feet away from itself, and potentially kick some firebrands into the green, where you're going to be chasing some new fires. Next slide. So after dust devils, fire whirls actually form in a very similar type of way, but obviously this is an indicator of very unstable air, but then you also have the addition of fire within that whirlwind. Extreme fire, this is a form of extreme fire behavior, and fire whirls can be very, very unpredictable. Many burnovers, including fatality fires, have resulted from fire whirls. So if you come into this situation where you have fire whirls, make sure that you're being accountable. You know exactly who all is in your division and who all is accountable to you. Make sure that people know where you are, because some of the times we've actually seen people wandering into these areas, and they may be in a place where they weren't supposed to be. So the other thing I was going to say is that when you see a fire whirl, and you may be tempted to take out your phone and start snapping pictures and videos and stuff, please make sure you give these plenty of room for safety. Back people up, make sure that you kind of sit tight and wait for these to dissipate, because you have no idea which direction these things are going to go. And that picture on the bottom left there, that's actually a photo of the Loyalton fire tornado, which we had in 2020, just northwest of Reno. And that Loyalton fire tornado, we actually issued a fire tornado warning on that one because it was such a large whirlwind. We could actually see it from our radar a number of miles away, and see that rotation as that fire whirl progressed across the landscape. Next slide. So this next video, this is from the car fire, and we talked about the car fire plume and how incredibly unstable that day was. And we're looking at the fire whirl that actually developed on the west side of Redding, within the suburbs of Redding. And luckily, this fire, there was as the fire progressed, there was an alert that was put out, and we actually told the fire agencies, all the firefighters, that this fire was going to move across the Sacramento River into the suburbs of Redding. But unfortunately, there were some fatalities that occurred as this fire became extreme and turned into a massive fire whirl. This fire whirl was huge. It lasted for over an hour. It had a path of destruction that was about 2 miles long and about a half a mile wide. So very incredible amount of damage that occurred from this fire tornado. Next slide. And we'll see how this goes. Actually, let's skip this one, Eden, because I don't think it's going to play very well over this medium. So the large fire whirl or fire tornado, we ended up calling it a fire tornado because it was much larger than what we typically see as a fire whirl. This fire tornado actually occurred. We measured the damage, and some of the damage actually created the equivalent of an EF3 tornado damage. Those high tension power lines that you see in these pictures were just crumbled down like a little piece of paper. Those high tension steel power lines are made to withstand an incredible amount of wind. And to bring something down like that, you need over 143 miles an hour of wind. So that's why we were able to rate it at an EF3. Next slide. Some of the damage that we saw on this fire was just incredible. Pipes and, wrapped around trees. We saw, cars that had been flipped up and tossed, half a mile away. There was a Connex box that we found in the bottom of a little ravine. This Connex container, one of those large shipping containers, we tried to figure out where it came from. We had to find it on Google Earth, and we ended up finding that Connex box, the shipping container, actually started a half a mile away. The tornado had picked it up and thrown that shipping container a half a mile, and those shipping containers weigh, something on the order of like 20,000 pounds. They're incredibly heavy. So just an idea of the amount of power that was associated with this fire tornado that occurred on the Carr fire. Next slide. And here's actually, if you go back one more, here's a picture of one of the neighborhoods, and you can notice this neighborhood did not burn. This neighborhood was completely spared from the fire, but not spared from this fire tornado. The tornado actually left the fire's edge and continued to create tornadic damage into some of these neighborhoods. I believe this was the Lake Redding Estates on the west side of Redding. And you can see the damage that had occurred, damage to the roofs, damage to trees. It was an incredible amount of damage throughout this neighborhood. So, next slide. Okay, so about fire whirls, and the fire whirls tend to form whenever you have the sun perpendicular to a slope, minimum clouds, very low humidity, prevailing wind across a ridgeline, or it can also occur at spur ridges in a canyon or sharp bends. Anytime that you have circulations of air that can get wrapped up into the convective column of a fire, that's when those are very common areas that we can see fire whirls occur. Also, points where the slope changes abruptly, or the fuel quantity. If the fuel quantity increases abruptly, ravines, box canyons, these are all areas that you can see fire whirl development. This video in particular is on the Indians fire. On the Indians fire, I believe it was 2009, back on the Los Padres National Forest, and that one actually resulted in a entrapment and a couple of engines getting cut off. But basically the three ways that fire whirls are formed is either thermally, a thermally driven convective column vortex, or wake flow around an obstruction. And those are the three ways that these fire whirls or fire tornadoes can form. Next slide.
All right, so transitioning just a little bit here, another thing to be concerned with as a wildland firefighter or a firefighter on the line is thunderstorms. So we're going to look into a little bit of thunderstorms and what are some visual cues of thunderstorms. So what we have here, what ingredients do we need for a thunderstorm to develop? First of all, we need moisture, unstable atmosphere, and then some kind of trigger that sort of forces that moisture and that air mass up into the atmosphere. So one indicator is if you see some of this fair weather cumulus, especially early in the day. I know if I wake up and I see some of those puffy cumulus clouds out already, that's kind of an indicator that there's moisture in the air and that it's a little bit unstable, and we could see some things forming midday or in the afternoon. Another really good visual cue, especially around here, is seeing those altocumulus castellatus. So those clouds sort of, if you see sort of like castle-looking puffy clouds, especially in sort of widespread areas in the morning, that's also a really great indicator of widespread moisture and some unstable conditions. I know that if I see these when I'm driving into work in the morning, that it could be potentially a very interesting afternoon in terms of thunderstorm development. So one of the ways that thunderstorms can develop is we see those wind flows driven by the terrain. So we will have those upslope, up valley winds, and when those air masses collide along the ridgeline, that's why we'll see those cumulus clouds typically forming along the ridges midday or during the afternoon first. And then a lot of times what we'll see is that westerly zephyr pushes in and can kind of trigger them to even be more interesting or more developed by the afternoon. So going through some other different stages of thunderstorms and visual cues, these towering cumulus, when you're really seeing those fair weather cumulus growing, getting more vertical, just getting overall larger, then you can tell that things are sort of escalating. And might potentially end up being into more of this cumulonimbus with this classic anvil top. So when we have this going on, when you're seeing towering cumulus during the midday, that's really a good sign to, especially if you're out hiking or out enjoying the outdoors. It's like, oh, maybe I should start thinking about having some exit strategies to get indoors in case some lightning or rain starts to form. And then once you have something that's very well developed like this cumulonimbus with that classic anvil top, that's a very mature thunderstorm. That's where we have the potential for seeing those really gusty and erratic winds. There's potential for hail, there's potential for lightning, and that can also be a great risk to those who are outdoors and along the fire lines. So we just threw up some pictures up here of some examples of what a dry thunderstorm could look like. Or a wet thunderstorm. So when it comes to being concerned with thunderstorms developing across the area, there are lots of different risks to assess as you're out in the field. With these dry thunderstorms, you can see that there's obviously lightning involved, and the rain shaft is barely visible. So what you can see here is the cloud up top with that dry thunderstorm, and then you have vertigo coming down where that rain is evaporating before it hits the ground. Now that's going to do a couple things. Number one, we're not seeing rain hitting the ground, which is a problem if we're going to have some lightning, because then we could potentially have some fire starts with that. But number two, as that rain is evaporating, as it's evaporating, that dry air, that momentum is still moving towards the ground. So not only do you have no rain hitting the ground, you also have a bunch of gusty, erratic winds, some outflows that are going to result from dry thunderstorms like this. So a lot of times on these days when we see dry thunderstorms, we're not only concerned with the potential for lightning starts, but we're also very concerned for even stronger wind gusts out of these thunderstorms because of that momentum transfer from the evaporative cooling that's occurring. And so with these wet thunderstorms, this is just a classic wet looking thunderstorm. You can tell there's lots of rain involved with that, probably lots of lightning as well. So in this sort of situation, we'd be a little bit concerned with potentially flash flooding and not as concerned about potential fire starts, because hopefully if there are any lightning strikes, it's getting a lot of rain put down on it there. Just another couple different views from potentially underneath the storm. If you start to see these mammatus clouds out in the field, it's a very good indicator that it's extremely unstable and that there is a lot of moisture in the atmosphere. So if we haven't seen thunderstorms forming yet, be on the lookout for the conditions to worsen rapidly. We don't get these all the time here, but when we do, while they can be really pretty, especially around sunset, it is an indicator that things might be escalating rapidly in terms of thunderstorm development. And then up here, this is just a nice picture of a rain and a downdraft from a thunderstorm. So again, what do I mean when I say downdraft? You're just looking at that rain along with those winds kind of like dropping and pouring out of these thunderstorms and colliding with the ground. And that downdraft is what's going to impact the surface and produce those outflow winds that can be of really great concern. So in terms of summer hazards and just fire hazards when it comes to thunderstorms, this is the pattern that is usually going to produce those kinds of conditions that are ripe for thunderstorm development. So we'll have an area of high pressure that forms over the Four Corners area, and that really just kind of circulates that big monsoon moisture into Southern California, Southern Nevada, and then up into the Great Basin area. So when we're talking about a Four Corner ridge or a Great Basin high pressure, this is something that you want to key in on, because we're going to be seeing that southerly flow increasing across the area. So that southerly flow is going to bring in that moisture from the Baja area and the Gulf. And it's going to really increase the potential for thunderstorms, because usually during the summer, we already have the heat. It's going to be really hot. So once you add in that moisture and the converging flow along the ridge lines, then it can be kind of a big problem. And the thunderstorms, they not only bring the risk for lightning hazards, but also the risk of debris flows, and that's going to be in those areas, especially that have already burned over, and you can see these very heavy rains impacting these burned over areas. So one way that we indicate the potential for thunderstorm coverage or lightning potential is with this lightning activity level. So we're still moving down that fire weather planning forecast through our different weather parameters here. So the LAL is going to kind of be an indicator of increased clouds, increased storms, and increased lightning frequency for these lightning events. So at the core of it, the forecast is based on what the thunderstorm coverage is expected to be. But at the end of the day, what you really want to be concerned with is when you see an LAL of 6, that is when we are forecasting the potential for widespread dry lightning. So when we have these thunderstorms, we're obviously concerned about lightning, we're concerned about erratic winds, hail, rain, all these things. But really, when you see that LAL of 6, that's when you should be pretty concerned. And when we're looking at an LAL2 of 3, those are kind of sneaky days when it comes to the forecast. Usually that means that we're forecasting isolated, wet, dry, kind of hybrid storms. And it's more in that transition from, we're not going to see all dry thunderstorms. Some of them may be coming a little bit wetter, but a number of them might still be dry enough to produce lightning starts. So in terms of the lightning risk, basically when you hear thunder, lightning is occurring. Lightning can strike more than 10 miles away from a storm, also known as a bolt from the blue. When you hear thunder roar, really you should remain sheltered for at least 30 minutes after that last thunder roar. We know that these aren't always possible, especially when you're out in the field. But if your only option is that you have to be outdoors, one way that you can kind of calculate the distance in miles is the time in seconds from the flash to the thunder divided by 5 will give you that distance in miles. So just another risk to kind of be aware of. One term that we throw around is when thunder roars, go indoors, or when you see a flash, you should dash inside. And again, if that's not possible, your best bet is probably to be as near as you can to a vehicle to get inside that vehicle to protect yourself from lightning. So like I kind of was insinuating, there are no safe places outdoors in a thunderstorm. Trees, towers, mountains are often struck, the high points, and you can see how destructive the lightning can be. So if you can, you want to avoid open fields. You don't want to be at the top of a hill or a ridge top. Beach shacks, tents, metal sheds, picnic shelters, ditches, not safe. You don't want to be in a ditch because you could potentially have some flooding. So if you can run, it's a good time to get to a car or a sturdy shelter as soon as you can. So that's basically your lightning and safety information for this refresher. Other risks that thunderstorms bring, and we talked about this a little bit earlier, but we're just going to dial into it a little bit more. Those thunderstorm downdrafts can produce winds of 40+ miles per hour, especially here in the West. A lot of times with these thunderstorms, especially if you're not from the West, you'll notice that they're very high base. They seem like they're very high up in the atmosphere. So when that wind and that rain has a long distance to travel down to the surface, we're really just giving it time to accelerate even more as it drops out of that cloud base. So when we're looking at thunderstorms and you have this virga or rain dropping down, you can see the downdraft sometimes, whether it's in the form of virga or a very, very dark rain shaft like we talked about with those wet thunderstorms. And as this downdraft comes down and impacts the floor, impacts the surface, those winds have to go out somewhere. So that is where we get the term outflow. It's these outflow, gusty, erratic winds from these thunderstorms. And they can produce very widespread haboobs or dust storms that can be really devastating, especially out here in the West, and especially considering the very dry conditions that we've had recently. So severe thunderstorms are typically categorized with gusts above 60 miles per hour, and you can actually see hail of at least golf ball size or bigger. And we have seen events in the Tahoe area and even in Reno where we've had those that 1-inch size hail. And at that size, that's when you're going to expect to see the potential for damage to vehicles, damage to potentially injury causing to life. So I know that we had a pretty decent thunderstorm a few years back that actually busted out all of our really nice looking patio lights in our backyard. And so while I was enjoying it as a meteorologist that we had very large hail, I was very upset that it destroyed our ambiance in the backyard. So yeah, other things, falling trees, damage to non-sturdy structures can be likely as well. You want to be concerned. The obvious threat with thunderstorms is going to be that lightning, but wind and hail are obviously also very, very concerning. So this is a really incredible capture of a microburst that the images are from the seismological lab and their webcams down there in the Las Vegas area, but it's going to be for one of these microbursts down in the Green Valley area. So we're going to watch this video really quick, and you'll really get to see these thunderstorms. Look at the amount of water. That's probably one of the most incredible captures I've ever seen of a downburst of a thunderstorm moving over an area. So we'll just watch this one more time so you can really get an idea and a feel for the amount of mass that is coming out of that thunderstorm there across the Green Valley area in southern Nevada. All right, and we have one more time lapse to show you here. This one is actually a time lapse of, oops, what happened there? All right, that's for the next, maybe this video won't play. So this is actually a thunderstorm outflow, a thunderstorm that collapsed over the Tahoe Basin, but we had ongoing smoke and fires going on. And you can actually see the progression of the outflow because of the smoke that's present. So it's just a kind of a really, although that was an unfortunate development for much of the Reno area when that smoke pushed in, and I think it soared our AQI levels into record setting, you can really see the amount of air and motion that is happening with these outflows that come out of these thunderstorms. All right, I'm going to let Alex take this next section.
All right, so this next video is actually a fire progression of the Yarnell Hill fire in Arizona, with which had the Granite Mountain hotshots. Is, you know, a terrible situation. This is a fatality of the 19 Granite Mountain hotshots, and what you can see is how this fire had continued to progress. It progressed from the south towards the north throughout the day, and actually, if you could pause it there, Eden, for a moment, you can actually see how that where they actually sat up on that ridge, and they actually had lunch up on that ridge top. They were actually watching the fire burn away from them during the afternoon hours. But then later on, there was some thunderstorms that were actually north of the fire area that had collapsed and were producing outflow winds, pushing the fire down and towards the south. The deadly thing that happened here was not only that the Granite Mountain hotshots, they left the black, they left that ridge line where they were safe, and they dropped off the edge down into that box canyon there, just to the east of the fire. And as they moved down into that box canyon, they lost sight of the fire. They actually knew that there were outflows in the area because there were weather alerts that were put out from the local weather office in Arizona. But you can see how quickly when that outflow hit the fire's edge, the flank of the fire became the head. And the head of the fire pushed rapidly down through that box canyon, and the Granite Mountain hotshots were trapped. They only had minutes. To pull out their chainsaws and try and cut out a deployment area for their shelters. Very, very sad situation. And you guys know the story of the 19 heroes, the firefighters that died that day. And this is an important lesson for all of us to learn, every single firefighter that's out there, and the new firefighters that are joining our crews, the new recruits. A lot of them have no idea who the Granite Mountain hotshots were. They have no idea what the Yarnell Hill fire was. It's really, really important to ingrain this into them, into their training, so that they understand the significance of what it means to be fighting fires and having thunderstorms in the area, and how quickly the fire behavior can change. So thank you, Eden. Next slide. So the other thing we were going to touch on, because this is actually a combination of what we were talking about earlier with the plume-dominated fires, can actually form their own thunderstorms if the conditions are right and there's enough moisture in the atmosphere. That not only is there moisture in the atmosphere, but it also combines with the moisture from the combustion of the trees and vegetation. You can actually see that pyrocumulonimbus form, and it actually forms a thunderstorm that can create its own rain and hail and lightning in association with the smoke plume. And that lightning can create new fires outside of the fire line. Okay, so these pyrocumulonimbus, this is again a situation where the fire creates its own weather. Very, very hard to predict, but when it is happening, we can let you guys know that this is what we're seeing on the radar. This is what we're seeing on our satellite, on the images that we're monitoring the weather. Next slide. The next thing I want to talk about is thunderstorm flash flooding. And flash flooding occurs when you have multiple storms dumping heavy, heavy amounts of rain, when you have those monsoonal situation, that monsoonal moisture that pushes up from the south, and you end up getting these storms that can produce 1 to 2 inches of rain per hour, or even more. Whenever we see the conditions that are ripe for flash flooding, we will issue a flash flood watch for the area. If you see a flash flood watch that's in effect, please be aware that the recently burned areas of steep terrain are especially susceptible to flash flooding, and camping or setting up of equipment right along dry creek beds. If you have any thunderstorms in the forecast, it's very unwise to do this. Please be aware that these flash flooding, the debris flows can travel for miles and miles away from the actual thunderstorm. Very critical weather pattern. Next slide. So this next video, there's a couple of videos, hydrophobic soils, and we'll look at the one on the left first. And you can see how the water, as we pour the water onto the duff layer, onto the normal ground, the water just gets soaked up very easily by all of the litter on the ground, that duff. It just kind of soaks it up. But on the right-hand side, if we watch the right-hand video, it actually shows what happens when you have hydrophobic soils. That water gets poured onto the hydrophobic soil, and there's nothing to soak it up, and so it runs off very quickly down the slope. And you can imagine what would happen when you have tens of thousands of gallons of water that are falling from a storm all at once, and what happens to the side of a mountain whenever that occurs. All of the debris, all of the rocks, all of the burned trees and ash falls down the mountain at the same time, and that's what creates that situation where you have that severe debris flow. And people have died from these debris flows. They're incredibly dangerous. So please be aware of, if you have that flash flood watch in effect, any kind of flash flood warnings, that's when you're going to see the situation where you could have these debris flows. Next slide, please. So the next thing I want to talk about is the mixing height, which is another measure of stability. So we're moving down. We continue to move down the fire weather forecast. The mixing height predicts how high the smoke is going to rise within the column. This is a very key element for prescribers to know how high your smoke is going to be traveling in the atmosphere. And if you have a very low mixing height, you know that the smoke is going to get trapped down into the valleys and potentially smoke out towns. Mixing height is, because it's a measure of stability, you can use it in conjunction with your Haynes index and look at if your Haynes index is a 4 or 5 or a 6, you can actually look at the mixing height and see how high your mixing is going to be that day. If the mixing is going to be up to 20,000 feet or more, then you know that particular day is going to be very, very unstable. Next slide. The mixing height does vary throughout the seasons. The summer typically has the deepest mixing heights, the deepest mixing layers, because we have the most direct sunlight. The solar angle is at the most direct angle. In the autumn, the fall, and in the wintertime, our sun angles are really, really low. So we actually have the least amount of daytime heating, the shorter daytime, the daylight time during the day. That's why we have the lowest mixing heights typically in the fall and in the wintertime. And then we have the springtime, which is kind of in between. Usually the solar angle begins to rise. We have longer days in the springtime. That's why we get the increasing mixing heights during the springtime. Next slide. The next element on our fire weather forecast is the transport winds. The transport winds are the average winds over the depth of the mixing height, right? So like we have that mixing height, 16,000 feet. what is the average wind over that 16,000 foot of mixing, and that is what our transport wind is going to be. The transport wind is similar, can be similar to the 20-foot wind, especially if you're under an inversion. But if you're not under an inversion, usually transport winds can be much higher, much stronger than your 20-foot winds, because you have those higher winds aloft that are actually helping to transport out the wind. Next slide, or transport out the smoke, excuse me. And the last one on there is the dispersion index, which the dispersion index is a combination of the mixing height and transport wind. This is actually a very easy way of looking at that mixing height and transport. If you have a combination of good transport winds and good, very high mixing heights, your dispersion is going to be very good or excellent. And this is based off of a study that has been used, a study that was done in Arizona, and is actually proven to be pretty useful for California and Nevada. So you're actually seeing a lot of offices in California and Nevada beginning to use this dispersion index as far as how your smoke is going to be dispersed. Now, this can be used during the summertime for fires and also for prescribed burn purposes as well. The last thing that we're going to talk about here is the chance of wetting rain. The chance of wetting rain is different than the chance of rain. Okay, this is very important to understand. A wetting rain is considered to be 1/10 of an inch, 0.10, in 12 hours. A chance of rain is only a 1/100th of an inch of rain. So very, very little amount of rain for the chance of rain. But a chance of wetting rain is specific to fire weather, because we want to know what is the chance that we're going to get enough rainfall that it's going to affect the fuel moistures and lower the fire activity or lower the fire behavior, okay? That's why we break out this chance of wetting rain as opposed to just a chance of rain. So again, this is directly tied into your fire behavior forecast. What is the chance that we're going to see sufficient rainfall to lower your risk of fires, lower your fire behavior? Next slide. Post-fire, and we touched on this a little bit earlier, but the post-fire floods and debris flows, we have a lot of burned areas around the region. This graphic is actually a little bit old, so you can continue on even to the next. There you go. You can see the pictures of what a debris flow actually looks like. This actually was a photo taken along Highway 395 after the debris flow off of the Slinkard fire that was near Topaz Lake. And you can see the amount of debris that just came off the hill. This was from a post-fire area. There's a burned area that received this area flash flooding and all of that debris that came down. So the worrisome scenarios for these are obviously with the thunderstorms, which we've been talking about with heavy rainfall rates. It could also occur when you have a cold frontal band or an atmospheric river, that you have plenty of heavy rainfall rates that could saturate the soils and give way to flash flooding. But the most of all, the most worrisome scenario for us is actually the thunderstorms that are bringing the heavy rainfall rates that can trigger the debris flows. Next slide, please. And that brings us to the end of the fire weather refresher. Down here at the bottom, we have our links for the weather.gov/fire. That is our National Weather Service fire weather page, and the national page for spot weather forecast, weather.gov/spot. Our phone number, and I'm going to give out our phone number for the National Weather Service in Reno. It's 775-673-8105. You guys can call us there 24/7 for your fire weather needs. But yeah, this has been Alex Hoon and Eden Wyson, and thank you guys so much for joining us. And I hope that you guys can send us back some some feedback. Let us know if this was a good fire weather refresher for you guys. This is our first time actually doing a recording. So thank you guys for joining us, and hope you guys have a wonderful day.